Another powerful tool you can use to optimize for performance is child processes. So we're going to do that within our CLI. We're going to modify one of our functions, one of our responders, to use a child process rather than the built-in library that it's using now. As I mentioned in the section overview, using a child process allows you to call any other application that might be living in the system that you're running on. And so you can think of a child process as giving you access to the shell, to the terminal. So any application that you could boot up and read input from if you're living in the terminal, you can access from child process. So what we are going to do is change the responder that lists out logs to, rather than using our built-in _logs list function, it's going to call the shell, and it's just going to use the shell on this system to call ls within the directory where all the logs live. In the wild, you can spawn a process to call any kind of application that you want. If you have some kind of compiled binary that calculates pi, for example, then you can call that and pipe in the output back into your Node.js application. In our simple example, we are just piping in the outputs of a simple shell command, but these really could be any commands that you can think of. So before we do that, let's go up to our dependencies and require child process. So I'm going to say that child process equals require child _process. Now let's go back down to our list logs function. To review how it works now, all we're doing is calling our log library, telling it to list out the logs, telling it that we do want all of the logs, even the compressed ones, and then putting in a vertical space, and then cycling through each of the log file names in the resultant array and logging them to the console, each followed by a vertical space. So we're going to do this exact same thing. It's just that we are going to get the array of file names directly from the shell instead of from our built-in library. So for now, I'm just going to move this section of the code down here on the assumption that we are still going to end up with an array that we need to cycle through. We're going to rewrite the rest of this. So let's start by doing the ls. So I'm going to call ls equals child process dot spawn. So we're spawning a child process with the command, the shell command ls, and we are telling it to execute that command within a specific working directory. And that working directory is going to be put inside of an array, and it's going to be /logs, because remember the name of the logs directory is actually .logs, and then another slash. Now, we have this command being executed, but we need to pipe the output somewhere. So we want to say ls standard out on data. In other words, every time this command starts piping data to standard out, let's catch it here. Let's bind to that. So it's going to call a data object, and we are going to want to take this data object, convert it to a string, and then split that string into an array. So we're dealing with an array just like we used to. So explode into separate lines. We want to say that the string version of this object is just going to be data object to string. And then the actual log file names is going to be data string split on the new line character. Now, let's go ahead and paste this part that we took out back inside so we can keep using it. We want to put in a vertical space, and then for each of the log file names, we want to cycle through it. But as you're aware, when you do an ls on a directory, it's possible that some operating system files of various kinds might be there. So before we log out everything, we want to verify that the things that we're logging out really are the type of file that we're looking for. So before we log out and do the vertical space, let's just put in an if. So we already check it for a dash, but let's make it a little bit more robust. We want to say if the type of log file name is a string and log file name length is greater than 0 and it has a dash, just to add some extra bulletproofing here. If it has a dash and it is a string, we'll assume that it's the ones that we're looking for. So let's go ahead and start this app up. The CLI is open. Let's call the list logs command. And you can see it's working. We're listing out all the same files as we were doing before, but last time we were trimming off the .gz, .b64. So let's go ahead and do that too. In our console.log, let's just call log file name .trim and then split it on the dot and take the first element of the resulting array. In other words, split this whole string on the dot, which is going to end up as different elements in an array. This is going to be the first element in the array, and that's all we want. So let's try this again. List logs, and there we have it. Same output as we were getting before. We're just acquiring it in a very different way by calling in the built-in ls function instead of our data library that use the fs functions to read all of the elements in a directory. Again, this is not necessarily a faster way to do it. I don't know that ls is any faster than the fs module would be. It might be the same, it might even be slower, but this is an example of how you can use commands from an alternative application or from the shell to take the place of something you might be doing in Node if that alternative is going to be faster. So this is something that you'd be doing as you do performance optimization. So now we can kill this app and move on to the section review.